Hello friends, from today I'm starting a series for learning Selenium in depth. We'll talk about a lot of concepts, all from the beginning and from the internal working perspective. Please like, subscribe, and click on the bell icon to get the notification for upcoming episodes on the series. Today we'll be talking about Selenium architecture and we'll talk about it in detail, understanding what is the concept behind it. All right. So without wasting much time, let's get into the topic. Let's get started. We'll learn about Selenium architecture. Before talking about Selenium architecture, let me quickly recap about what Selenium is. Selenium is basically a web automation tool which we use for cross-browser testing where we write codes in different languages. The concept of architecture here comes in place when we are talking about how the code that we have written in any of the languages, let's say Java, Ruby, C Sharp, how does it get converted into commands which gets executed in the browser to give us response, to give us desired output. Let me start by saying I have a box where our codes are written, let's say in Java. So once we have written this code, till we were with Selenium 3, these codes that we have written in any of the languages were getting converted into a JSON payload. And that conversion was powered by a protocol called JSON wired protocol, right? So there is a box where you get all the codes that we have written converted into JSON payloads for the request, which is being sent to the browser for our execution. Now, this JSON wired protocol, once it converts the payload, this is now communicated or this goes to the next set, the respective browser drivers. Now, while it sends to the browser driver, it follows a path. It directly doesn't communicate with the browser driver. It communicates with WebDriver, followed by remote WebDriver, and followed by the browser driver. So, logically, what happens? The first place where it goes is the WebDriver. From the WebDriver, it goes to a place called the remote WebDriver. From the remote WebDriver, the whole thing is now communicated to the actual browser drivers. Now, these browser drivers, if I have created a Chrome driver, it will be able to communicate with Chrome browser only. If we have created a Firefox driver, it will be able to communicate with the Firefox only. Now, the code that we wrote in any of the languages got converted into JSON payloads. The JSON payloads now got converted into commands using browser drivers. These browser drivers communicate with browsers, but the browsers and the browser driver for communication, again, it requires another media, and that media is HTTP protocol. Over here, let's say we have the browsers, let's say Chrome or Firefox, Safari, Edge, or any of those browsers. Now, if you see the flow, what happens is the code first goes from any of the languages, gets converted into JSON payload, that goes into the WebDriver. The WebDriver then goes into remote WebDriver. The remote WebDriver sends the request to the browser driver. The browser driver is then sent to browser using the protocol called HTTP, and that completes the flow for the code reaching the browser. But whatever happens in the browser, we need to get the response back so that we know what has passed or what has failed. So it follows the same flow from browser to HTTP, from HTTP to our driver, and from the driver to the code using following the same path of JSON wired protocol. So this is what Selenium 3 looked like. Now, there are two important things that we need to talk about. One is this JSON wired protocol. What is this JSON wired protocol? To understand what this JSON wired protocol is, we have to first understand what is the language that we are writing here and what is the browser language that it understands. What I mean to say is, browser does not understand our native language like Java, C Sharp, or Ruby. It understands its own language. The code that we write does not understand what browser says. So there's a gap between both of them. The things that we see here, the JSON wire protocol or the HTTP, acts as a translator. Now, this translators converts the code from a normal native language that we would have chosen and written the code in into a JSON payload, sends it to the browser via browser driver using a request, and the response again follows the same path. As you would even imagine, whenever we are talking about translating things, definitely it requires time. Definitely the person, in this case the protocol, needs to understand the code, convert it into the required command. It takes time. Because of it taking time, lot of code became flaky. To overcome this problem, Selenium came up with a new architecture where it directly removed this JSON wire protocol because it wanted to avoid the need of translation, because it wanted to fasten the pace of execution. So what did it do? If we talk about the new architecture, which is from Selenium 4, by the way, just a quick information, Selenium 3.8 had both the architecture in place. We could have used either one of them. From Selenium 4, it is completely the new architecture that we are going to talk about. Anyway, the language that we would have chosen for our code writing remains the same. We can write the code in any language that we prefer. Once we write the code in the languages specified, Selenium uses a different protocol now. That protocol is called W3C, or World Wide Web Consortium. Now, what does this W3C do? W3C, or World Wide Web Consortium, transfers the request that we have written in any of the languages to our browser. But here the catch is, or the plus point is, both the things follows this protocol. Every language in today's world follows the W3C standards. Every browser follows the W3C standards. It's basically two people who knows the same language communicating among each other. If we visualize it, this becomes faster, this becomes easier to understand for the browser and for the code, which reduces the time. And because the time is reduced, the executions become faster, the flakiness is reduced. So let's understand the whole flow. Now, this gets converted into our browser driver. So what Selenium 4 has done is, after sending the code, there's an addition of a Chromium driver, a parent driver which is in place now. After this message is sent into our browser drivers, it communicates with the browser. Now the request is sent to the browser using a new protocol which is called the DevTool protocol or the native support. For the browser drivers communicating with the browsers, there's a new protocol in place which is called DevTool protocol. And this native support or the DevTool protocol converts or sends the request to the browser. Whenever you open a browser, right click on any of the element and inspect, you would be able to see a dev console. So the protocol over here that we are talking about follows the same. Now, Selenium 4 uses the same DevTool protocol provided by many of the browsers to enhance our tests. Going forward, the plan is to implement WebDriver BD. Because it is not in place as of today, we are still falling back to the DevTool protocol. In future, we would see something called WebDriver BD. That's the next gen implementation for W3C. And that will enhance our test in a lot of ways that we could have not imagined. Using DevTool protocol, we get some enhanced features like performance metrics, geolocations for the driver, etc., which is going to get enhanced further when we use the WebDriver BD. For now, W3C protocol combined with DevTool protocol still reduces the time, reducing the flakiness, improving the performance of our tests. That's a short video for today. Thank you for watching. Please do like, subscribe, and share.